welcome to my channel. This is my little platform where I turn struggling math students into math masters, and I post videos Tuesdays and Thursdays, so subscribe and turn on the notification button if you want to know when I post any new videos. I do want to add that I encourage you to use the playlist option on my channel, because in the playlist option you will find all the different grades that I create videos for, the specific topics that is covered in the subject, and you can find all the videos related to that specific topic in that specific folder. I think that's just an easy way for you to navigate this channel, because I've gotten a lot of requests on videos that I have already made. So I'm just worried that the problem is not that the videos aren't there, it's just that you don't know where to find them. So please, I encourage you to use the playlist option. Alright, so in this video, I'm going to be looking at packaging, the most requested video and topic being asked. There were so many people who added in the comment section that they want me to do this video, so here you go. Alright, so this is your lesson on packaging, and I have removed my face from this lesson just because so that you are actually able to see the questions. But let's first start, like I always start, by the definition. What is packaging? So packaging is a topic under measurement where the objective is to calculate what the most cost-effective strategy is for packing. Okay, it also involves calculating how one container can store multiple items. So that is simply what packaging is I'm putting something in a package. So I'm storing something, and the calculation of how much I can actually store in a space is what most of these questions are based on. I've taken 2 questions from past papers that are on packaging, and yeah, I'm going to use these 2 questions to help you really just grasp your understanding on this topic. Okay, so we're going to read through all the information first before we attempt this question. The question on packaging essentially for this one is at 2.2, but I just decided I was going to add the entire question so that you are actually able to see how all of this, how measurement is also involved in packaging. Okay, so during winter, many children develop coughs. Cough syrups are sold in bottles packed in rectangular prism-shaped boxes. Children are given cough syrup using a cylindrical measuring cup. The diagram below shows the bottle, the box, and the measuring cup. So I look, okay, this is what the cough syrup looks like. The bottle goes into this is the dimensions of the box, and this is the cap. Then I see, okay, they give me 4 different formulas here, okay, and I will use whatever is applicable. And then at the bottom it says, use the information above to answer the questions that follow. So 2.1.1, the question asks, consider the cough syrup box. Calculate in centimeters cubed the total surface area of the cough syrup box. So the important thing that you would note in a question like this is in what unit they are asking this for. So this is in centimeters cubed, which means when I'm calculating the total surface area of the box, all the units that I have, all the measurements that I have must be converted to centimeters first, right? So that's how we will approach this. Firstly, I'm going to take the 125 divided by 10, and it will give me my 12.5 centimeters. Right? Again, I will take the 65 and divide it by 10, and that will give me my 6.5 centimeters. Now that I have all my measurements in centimeters, I can actually use the formula that they've given me to actually calculate the rectangular prism. And I just substitute my values into the formula. Now let me just show you what I'm doing here. When you're calculating surface area, the formula that they've given you is, if you take this, you see you get a top and bottom, you've got left and right, and you've got front and back. So if I were to take the front and the back, this would be 6.5 times 12.5, right? And that is multiplied by 2 because I've got 1 in the front and 1 at the back. Then plus 2, and this is left and right now. So on the left side, I've got the 65 that I've now converted to 6.5 times the 12.5, and that is what I have there. And then plus 2 will give me the bottom and the top values, which is the 6.5 times 6.5, and that will be 2 because there's a bottom and the top. I do have a video on total surface area where I break the surface area down of a rectangle prism slowly and in more detail. So if you need, if you're not too sure on what's happening here, please refer back to that video. Okay, so now that we have the total surface area, we just plug in our values, and the surface area then for this cough syrup box is 409.50 centimeters cubed. I have answered the question and I've given it in the unit that they've asked it from me. Right, B. Give a practical reason why a cartoon picture would feature on the box of a cough syrup for children. So here you'd want to think of different ways of how can you reason why there would be a cartoon picture on a box for children on the cough syrup. So already my thinking would be, okay, if the box is decorated nicely, if it's got a nice aesthetic, if it's aesthetically pleasing, then that means that kids would be more drawn to wanting to take the medicine. Okay, so how would I write it out? Now remember, mathematical literacy has two aspects to it. The mathematical part, which is like our calculation in this first question, and our literacy part, which is where you have to actually answer the questions by giving your thinking and your interpretation of what is happening in the question, right? So B will then have to make the medicine drinking process for a child more appealing. So any answer to that effect would get you the marks. It's important for you to start your sentences with a capital letter and make sure that you end it with a full stop, and then make sure that you are reading the answer so that it actually is clear to the person who's marking it. Because especially in the final exams, you do not have a teacher there that you know that is marking your paper. Okay. 2.1.2. Calculate in centimeters the height of the measuring cup if the diameter is 2.52 and the volume is 10 milliliters. So if you look at this cap now, right, they want you to calculate the height. Okay, so this is a cylinder, and what they do is they give you it's 10 milliliters, right? That's the volume. In other words, actually it's the capacity. What is the amount of liquid that can fit into this container? So what you are going to do is, because you obviously need to use the volume formula to find the height, okay? But you first need to convert the volume into, you have to convert the capacity given of 10 milliliters into volume using this rate that they give you here, and then use that answer to calculate the height. So let me show you what I mean. So first we're going to do is we see, okay, they tell us that 1 milliliter is equal to 1 centimeters cubed. Okay, so the 1 is, remember in my capacity and volume video, I explain the difference between what is the liquid and the volume, okay? So in this case, they tell us 10 milliliters. So that we can equate based on what they give us here, that 10 milliliters is equal to 10 centimeters cubed. So what they are telling us is that this cap, its volume, right, is 10 centimeters cubed. Now, knowing that, I can use the volume of a cylinder's equation to find the height. So this is how I would do it. So if you have a look here, this height, in order to do that, you actually need the radius, okay, of the cylinder. So 1, we found out what the volume is now, and then 2, we are going to convert the diameter into the radius calculation so that we can actually use the appropriate values in the formula, okay, because the formula says pi, which we know is 3.142, the radius, which is the 2.52 divided by 2, okay, because this is the diameter, and then you'll have to find the height, okay, because the volume of the cylinder is what we calculated here, which is the 10 centimeters cubed. So how do I express what I've just said in a formula? So if you have looked, this is what they give us, right? They say volume is equal to, and then it's the pi, 3.142, right? You see here, where's the volume now? Here, pi times radius squared, which is 1.26, multiplied by height. Okay, so the volume we know because we've calculated it here. So the volume is 10 centimeters cubed. And now I have to just get H by itself. And if you followed my videos, you've seen that any value that I take over the equal to sign to get H alone, I do the opposite operation. So on the right hand side, all of these are being multiplied. So if I take it over, I'm going to divide these values, right? So that means that my height is then going to be equal to 10 divided by 3.142 divided by 1.26 squared, and my answer is then 2 centimeters. So that means that the height of my bottle is 2 centimeters. Okay, so take some time to just have a look at this. Okay, rewind if you have to make sure that this makes sense to you. Okay, so this is just essentially 2.1.1 and 2.1.2. Now we're going to look at the packaging type question, okay, which is 2.2. So let's move over to 2.2. So 2.2 says the pharmacy received the following order of cough syrup. 5 large cartons of cough syrup, right? Each carton is packed with 4 layers of cough syrup boxes, and each layer has 8 rows of cough syrup boxes, and each row has 6 boxes of cough syrup. Calculate the total number of cough syrup boxes the pharmacist received. Now here they are just asking you to calculate. They're telling you how things were packed, and you must calculate so how many boxes are in there. So firstly, I've drawn one carton here for you so that whatever is happening in this one carton, you can just picture is happening in 5 cartons, right? Because there's 5 cartons here. So the first line says each carton is packed with 4 layers of cough syrup. So I want you to picture that there are 4 layers of cough syrup of boxes on top of each other like that. Okay? Then each layer has 8 rows of cough syrup, right, of cough boxes. So picture that each of these now will have 8 rows, right? So each of this will have 8 rows, and then each row will consist of 6 boxes. So they want to know how much do we have in total. So the way you would approach this, grade 12s, is very simple. You will literally say, there are 5 boxes, right? So you're going to say 5 because whatever we calculate here, we're going to have to multiply by 5. So we're going to say 5 multiplied by 4 multiplied by 8 because there's 8 in each, and then multiplied by 6. So you're literally taking all your values and just multiplying them by each other. So if it's easier for you to picture it as, okay, here I've got a row of 6. So I've got 8 rows of 6. That's this calculation, right? So my base of my box is 8 times 6. Then because I've got 4 of these, right, I'm going to say 8 times 6 times the 4. And then multiply by 5 because I have 5 boxes. So in total for this question, this pharmacist will then have received 960 cough syrup boxes. Okay, so this is more or less like a packaging question because your thinking has to be about how is this actually packaged into this box. All right, so this is a little bit more tricky question, okay? And yeah, but I think, and what I've done is I've literally just taken out the question that has to do with packaging. So this is a 9-mark question. So I understand why a lot of you have asked and requested this question, just because it is heavy-weighted question and sometimes very tricky to understand. So the first thing you're going to do is you're going to read all the information given to you. And then you're going to try and decipher what it is that they're actually asking. So at the top, the information given here is about the can, the dimensions of the can, right? And then they give you 2 formulae. And essentially here they give you what the weight of a can is and then what the dimensions of the label of the can is. So that's the information given in the first block. The information given in the second block is as follows. It says, some of the cans of fish are imported by ship. The cans of fish are wrapped in packs of 12. Then they show you how it's wrapped, right? So this is how it's packed. And it's going to be packed into this shipping crate. And then it gives you the dimensions of the 12 pack, which is this. right? And then it says, further information, the mass of an empty can is 40 grams. The mass of a fully packed shipping crate, which is this with cans in, is 280 kgs. The inner dimensions of a shipping crate are 117 centimeters by 66 by 50. That's the information that they're giving you there. Packs of cans are placed lengthwise, length to length, in the shipping crate. So this is very important because it's saying the length of this box, right? This length is going to be packed along the length of the actual crate, right? And you'll see in a moment why that's important. So the question basically states the following. Aggie stated that an empty shipping crate has a mass of less than 20 kgs. Verify with calculation if her statement is valid. So we have to check and do a calculation to see if this empty crate has got a weight of 20 kgs. Okay, so I'm going to reframe this question for you so that you can actually understand what is being asked. What they want to know essentially is they are giving you 3 phases here. So we've got the container with cans, right? So this is the crate with the cans. They tell us here has a mass of 280 kgs. Okay. They want to know that what is the weight of this container without the cans. So automatically your brain's like, okay, so I actually have to figure out what is the weight of the cans so that I can then take the weight with the cans, subtract the weight of the cans, so that I can actually find out what is the weight of this without cans. Because this is what I have to prove whether or not the mass is less than 20 kgs. Okay, so this is essentially what is being asked. Now, most of the calculations for this question, grade 12, is going to come from this section here. Is calculating how many cans actually fit in this container. Once we find out how many cans, we then calculate the weight, and then we take this box's weight with cans, subtract the weight of the cans to give us the container's weight without the cans. Okay, so let's do this. Firstly, we need to find out how many crates of 12 of these packs of 12 can fit into our crate. So like you heard in this question, it says length to length. So I want to see how many can actually be packed next to each other. And the way I do that is I'll take the 117 and I'll divide it by the length of the pack of 12. So this will tell me how many can actually fit next to each other. Okay, so I'll have 117 divided by 29.2 gives me 4. That means in this crate, I can pack 4 stacks of 12 next to each other this way. Okay, now how many can I pack this way? And the way I do that again is the 66 divided by the 21.9, because this is the width of the crate divided by the width of the cans. Right, so it's the 66 divided by the 21.9, and there I get 3. Okay, so what have I actually calculated here? I've got 4 can be packed this way and 3 can be packed that way. So essentially, I will have 4 multiplied by 3 packs just at the bottom of this crate, right? Which is then equal to 12. So I have 12 packs of 12. Okay, because remember in each pack there's now also 12 cans. So that means that in total in my base part of this crate, I will then have 12 times 12 cans, because there's 12 packs that can fit in the base and there's 12 cans in each pack. And that means that I have 144 if I just pack the bottom part of this crate. Now I want to find out how many can I actually fit on. So now I would then calculate 50 divided by 10.8, and this will tell me how many packs I can actually pack on top of each other. So this is 4. So that means if I can fit 144 cans at the bottom part of this crate, then I would multiply it by 4, because now I'm going to have 4 layers of 144. So that means in total, I will have 576 cans that can fit in this entire crate. Okay, now pause, go back, put the video on a slower speed if you need to, so that you make sure that you understand every step of this question and this calculation before you move on. Okay, so what we've just calculated is that there are 576 cans that can fit into this container, into this crate. Okay, now what we want to do is we want to see, okay, now that we know how many cans, we can work out how heavy they are. Because in the question at the top here, it says that each can is 400 grams. So if I have 576 cans, I can multiply it by 400 grams, and that will tell me how much total weight I have in grams for the amount of cans that can fit in this crate. If I convert this answer now to kgs, then that means that 576 cans is equal to 230.4 kilograms. So what did I just calculate? This part here is 230.4 kilograms. Now do you see, I can just say, if this is the weight with cans and this is the weight of the cans, then the weight of the container without the cans is going to be the 280 minus the weight of the cans to give us 49.6 kilograms. Okay, and that means that her statement is invalid because she says that the crate has a mass of less than 20 kgs. Now here it says verify if a statement is valid. So you have to add as your final answer, you will have to then say her statement is invalid. Okay, so let's just quickly refresh. We know that this question asked, what is the weight of the container without the cans, right? So first thing we did was calculate how many cans can actually fit in here. We calculated how many can fit along the length, how many can fit along the width, and then how many can fit along the height. We multiplied these values together, so it's the 4 times the 3 times the 4, right? And then multiplied by 12 for each pack, and that would give us 576 cans. Once we knew how many cans, we could then multiply it by the weight of each can, and that would give us 230,400 grams. We divide this by 1,000 to convert it to kilograms so that we can actually see what's the weight compared to what the weight is with the container. Okay, so we've got 230.4 kgs. To then find the weight of the container without cans, I then took the container with cans minus the cans, and I could actually get the calculation of the container without the cans. And then you have to remember to actually say that the statement is valid or not. Okay, and that is packaging. Alright, so there's that video. I hope you found it helpful, and if you did, I would appreciate a thumbs up, I would appreciate the love, I would appreciate the comment in the comment section saying, how you found this video and letting me know sort of how you feel, if you feel confident about the section. And then also if you have any questions or recommendations for future videos, you can also add that in the comment section below. Then, yeah, thank you so much for watching, and I will see you in the next video. And for those of you who are writing exams, I hope it goes well. I'm sending all the good love, and I hope that you are focused and that you actually can do really well in these exams. May the force be with you. Bye, guys.